I think the majority of the class did the assignment last night, so you
I
weren't
did
alone.
it last night, so I didn't get the last night. I just went to some.
I looked at that yesterday and I was like, oh man, I should send out a reminder because like, does anybody know what's out there?
You did.
Yeah, there's always some people that do it really early on the list, but
You
man,
did say to start doing them more early because the assignments start getting pretty lengthy, right?
yep, they will. And I mean, it'll kind of go up and then take a dip and then go back up. And then of course you got the project, which will be quite huge.
On like the assignments, because the last one, it seemed like it was more of like a do it in one sitting. But in some of them, do you think you could like break it apart over like the course of a couple hours or a couple of days?
I don't think none of them should take a couple of
Well,
days.
I mean, like just pacing, like doing a part of it, then a part of it later.
I mean, yeah, you could. I mean, I don't know how you like to code on that, but I mean, there you could segment some of them, especially I think this next one, the entire assignment is actually two different exercises.
Oh,
So on that one, yeah, definitely you tackle one and then move on and then tackle the other. They kind of use some of the same resources, but they're two separate things. And then, of course, the grad students that it even expands further on that. How do you tell if someone has bucket fever?
they look pale.
Yes, they start looking a little pale. How does a con man sleep at night?
He pulls the sheets over his eyes.
He what? He lies on one side and then he lies on the other. There was one more. Yeah, how do spies keep warm? But stay undercover. That's pretty good. Wish this thing would go away. There, finally. All right. New stuff today. Oop, I need to set something up real fast. Oop. Gosh, that's getting way too long. Hang on, let's see, move. Sure, oh, I'm in it. Sure, yeah, supplements to just lecture 10. Man. All right, so let's get this started here. So I think I told you all about this the other day because we were talking about how we had the single left arrow, which was redirecting input. And then I told you about the triple arrow. Does anybody remember what that triple arrow was for? As in to when should we use one versus the other here? Let's start easy. What's this one for? What is it redirected here? Because that's the important part. A file, okay? So this one redirecting. A string, perfect. That could be a variable because the variable once evaluated, it's just a string. So that's the difference between those two and kind of governs when and we should and shouldn't use them. Now, again, I told you they developed the triple arrow because it already had a reason right here, and that is with this here document. And to kind of sum up what a here document is good for, it can be used for multiple things, but it probably what it's used for more than anything is when you have a whole bunch of text and you kind of want it all formatted. Normally you would want it one line after the other because that's kind of the big saving grace for it. You don't want to have to sit and type echo and then the echo statement, echo, then the echo statement. You can simply put it in a here document and you can make it as long as you want and it will just print as you type it. Oh, thank you. I'm terrible about that. Oh, I hadn't even logged in. Give me a second. I'll get that up. Hit refresh and it should be there now. All right, so you can actually put in several different commands here at the top right there. One thing that you can't do is the echo statement, because that's literally what it's doing. It's kind of replacing that echo. And then, so you've got your options and your arguments. Honestly, I don't use very well. I would say the options, you could have options to your commands in there, but a lot of the options to the actual here document. Hang on. I don't tend to use them that much, but then that is required. That's kind of that special operator. And then delimiters, you just kind of make up the delimiters on your own. They just must be unique, as they can be contained in the text that you're actually trying to get out there. So one of the common delimiters are these two right here, EOF for end of file or end. So you would just specify EOF here, and then you would have your code in between or your text, and then EOF. And so then it kind of knows where it starts and where it ends right there. And then here's kind of the common how it should look right there. Again, with your delimiter here in each of those on a different line, separate to your actual here document or the contents of it. So here's a good example right here. This one right here, we're going to use grep. We'll use something different right here, not mimicking like an echo. And then -I to grep, that is case insensitive. So now no matter how we type it, grep is still going to search for the text. And then $1 right here. So, again, this is in a script right here called here test.sh. So what is $1 representing in that? First argument. Good. So here we have that required, double delimiter right there. And in this case, you can put a space in between them. You can butt it right up against that. This was the delimiter that was used as a plus sign, because it does not actually, it's unique. It doesn't occur within that, document right there. So let's take a look at how it works. Again, I'll just cat out the actual here document. Oops. Called it here grep. So same contents right there, but now if I was to actually run the here grep command, if I give it no arguments, then it's simply going to print out what is in there. So you can see, we have this code at the top right here when I catted it out, but when I run it, that's not, this is what the here document. So it's just printing the contents of the here document. So you don't get the actual delimiter or anything in there. But when I give it an argument, let's just say June here, then you can see it's going to grep those lines that are in the document. So now you can see you've got June here and June there. So that's what was returned. And again, I could actually, since I did the case insensitive, I could do lowercase and it's still going to find those for me. Now, let's contrast that if we kind of use it as an echo statement right here in this here session. So close this up. So we'll cat out the here session. So again, we got our header right there. And then I'm using the cat command, because again, we can't use echo, because if you want to mimic the echo, you have to use the cat command. And then here we have EOD. It doesn't really matter what it is. It could be anything as long as it matches. And then you can see we also have command substitution and then a variable in here. So if I was to run this information here, you can see that now we've got that information being displayed. If I was to open up film, and I don't know if y'all caught that because I went through it so fast, for a strange reason, and I can't understand why, but if you want to suppress all of this expansion taking place in there, they do have a special setup for that. And that is if you put this in double quotes, and you can see the code is actually recognizing it. It's now just recognizing as strings. It doesn't recognize it as actual code anymore. So when we run it, you can see everything is a literal in there. And then if you wanted to like mix and match here, you could go over here and delete these. And let's just say this one right here. If I wanted that to be a literal, then I could go in here and just put an escape in front of it with that backslash, save it. We run it. Now you can see that is completely escaped. So it works just the same, luckily, as kind of our normal echo does within it. You just have that strange syntax of putting quotes around your delimiter, and it has to be the beginning one right there. So you will see this a lot right here, especially when people are trying to display text. This tends to be the way they like to do it, using that cat command within the here document.
Matter of fact, we'll be taking a look at somebody's code here pretty soon, kind of spending a class session going over the code, and they use it all the time.
Last slide. You have the quotes on the bottom one around the EOS.
Okay, so this one right here, crap, sorry. I added this morning and I copied this and pasted it here and put the quotes and just called it a done deal when it should be the literal in here. It should be PWD and good catch. Let me make a note to update here doc slide. All right, positional and special parameters. We've seen those time and time again. We're kind of expanding on those just a little bit. We did the online or I guess during the snow day. Did we cover the $star and $@ during that time?
$@ for all the arguments.
Yes, perfect. Okay, and the $star actually just creates like, no matter how many separate arguments you give to it, it just places it in one argument. So one string right there. It's kind of the big difference between those two. Now sorry, I'm going to have to step back on that. That is if they are within quotes. When they are not within quotes, they do the exact same thing, which is actually a list. So that's kind of an important thing. Of course, you should be putting quotes around all of your stuff. It's kind of a best practice. And that's kind of one of those reasons right there, because these just kind of lose their separate meaning whatsoever if you don't put them in double quotes right there. Let's see, of course, exit status. I want to remind you all of that. That's one of the things we visited several times so far, and we seem to struggle remembering what that is. So that is the success or failure of the previous command that was run. And then we've got $- right there. So that actually would hold the value of all the options from the command that was run. And then the $_ holds the actual arguments being supplied. So that if we had a script and we gave it an argument, then it would remember that argument there. And then we have set, which I know that we covered set, and set's one of those things that just there's actually 3 different methods. I think we'll talk about them on the next slide. That set just gets confusing because it has so many different things that it does. Yeah, here we are. So here you can see that it will list all the variables and functions that are declared on your shell. So that's if you just type set and just leave it at that. No arguments are coming after it. Just type set and it's going to give you all that information. We'll see later that we can provide some particular arguments here to set, and that will allow us to set and unset shell features. So basically control all the options that are in our shell. And then we see right here is what we're doing. We're using it to initialize positional parameters. And to me, this one's just like, really, I understand these two. I do not understand the last feature right here as to why they threw it in on set. But in our example right here, we have a script. And then we have the date command. Of course, we know the date command is being displayed and it kind of has a separation. So its delimiters are space, and that's what set uses as its default delimiter spaces. So if we set date, then it would then go to like Saturday here would be plugged into $1. That would be $2. And then we've got we got 3 right there. And then 1, 2, 3. Yeah, 6. I think I messed that. No, I didn't. Yeah, that would go to 6 right there. So it just kind of separates them out right there. And we can kind of take a look at that again. We did date right here. What did I call that? Date.sh. So if we did /date. Here. Now you can see kind of separating those arguments out. So the first argument is Tuesday, then March, then 4th in 2025 there. So this allows us to take any string and then assign it to positional parameters, because really the only way we have a way of doing that right now is if we supply the arguments to a script, right? And that's where we get the $1, $2, $3. Well, we can do anything within our script using set and then be able to reference those positional parameters. Matter of fact, we can use
the arguments being supplied, and then we can overwrite those arguments within our script
using set with some other type of command right there. Just one thing you have to remember with set is it does require that command substitution. You just can't type date. It will be a literal string and that's it, because that's what it's processing. It's processing a string. That's what it's looking for. So we got to throw in that command substitution for that to actually work right. And then kind of going back, we've already talked about kind of the $* and the $@, and then we're going to see an example that we can kind of visually see how that is taking place. And we'll just take a look at it in the code here. So I'm going to cat out the expand. We'll do the star first here. So in this one, we've got our shebang, and then I've got a comment. So this is an if statement, and I threw in a not right there. So this was the number of arguments. We kind of saw that's kind of a shorthand. So at first it's you know, by itself, it's just testing that there is arguments. But since I put a not, it's testing to see if there's not arguments. And then if there's not any arguments being supplied, we have a usage statement right here. That's just going to say, hey, it needs some arguments. Then if that gets displayed, of course, we want to have that exit 1. I don't have it in there. This should have the error redirection where it's redirecting to standard error, but I haven't updated all of my code on that. And of course, then we're just ending it. And then as you can see right here, because it's so short, I just made it a 1-line if statement. You just got to understand where to put in all of your delimiters to be able to do that. And I like to try to shrink things down to as much as possible. And then here I'm just echoing $pound. So that what's that going to echo? Number of arguments, perfect. Then I'm using set right here. And so I'm using $@. So that's going to process those arguments. It's going to send those arguments to set right here. So if I type in 1 argument, it's going to send it to set. If I type in 10, it's going to just send them all to set. And then I once again, echoing out the number of arguments. And the reason why I'm doing that is because we want to see if before and after set, what is actually happening with the number of arguments that exists there. And then I'm just telling you here, I'm just showing you, okay, we're actually running the $* right here expansion. And then I have the echo statements with 1, 2, and 3. So we're only going to do 3 arguments. And then here I'm showing you the end of the file right there. And it'll make more sense once we run it here when I'm trying to show you. So if we do expand star again, if I hit enter, it should trigger that, and it did. So it needs arguments. So we're just going to do A, B, and C here. So now you can see that first one that took place, the echo. So there's 3 arguments, sure enough. And then set gets run right here. And then since set is within double quotes, it's going to take all of those arguments, those separate arguments, and apply them to a single string. And now, since set has already done that, I'm going to get the number of arguments again, and you see how it shrunk down to 1. So now all those separate arguments, they're no longer separate. They're 1 argument. And then so they all belong to the argument 1. So we can say we echo that out, and these echoes are still there. They're empty. There's nothing, there's no variables to that. So it just kind of proves that whole concept there to you, versus if we were to take a look at expand @ same exact code right here, only the set changes right here. And of course, this echo changes. So if we run it, /expand @ oops, I can get my hands on the right row, B and C. Now you can see that the expansion took place, and it's A, B, and C. So this right here, I mean, it did absolutely nothing. There's technically no reason of doing this because they were already set to begin with. I just kind of want to show you a compare and contrast so you can visually see how that is actually happening there. All right. Okay. This one right here is pretty confusing. So I'm going to try to take my time and explain it thoroughly. So this is null and unset variables. So I've showed you before in scripts how we can just kind of declare variables. So that way we can see all the variables that are going to be at the top of our script. So we know that they exist in the script, even though we may not be giving them a value just yet. So if a variable, when it is evaluated, has no value, well, then it'll simply just, do what we did on the last screen, like the echo $2 and $3. It's still going to, echo is going to take place. It just has no value. So it just is, its value is a null string. It's just nothingness there. But we can actually kind of control if that actually occurs, then we could assign it either a temporary value we could assign it a permanent value, or we could assign it an error message. That's kind of the three scenarios that takes place right here. And of course, again, brace syntax right here. This is nothing new. That's just the name of our variable right here. So here's the new part. It's this colon dash, and the default represents whatever value that we want to give it. So we're giving it a default value if it has no value. So understand these three scenarios that I'm about to show you. If the variable already has a value, then it means nothing. It changes nothing. It will just ignore it, because the only time these right here, these default values or error message would get triggered is if the variable has no value whatsoever. So the difference with this colon dash is that if I was to put, say, this in an echo statement, and I was trying to echo out the name, but of course, for some reason, the name never got applied, never got triggered in our code, then I would give it a default value of, let's say, Jacob here. So we would do colon dash Jacob within that. Then once this gets triggered in the echo statement, if it doesn't have a value, then Jacob would be placed in there, and then it would be thrown away. It would no longer have that. So if we echoed out name again, then if it had no value, it would just be nothingness. Or if it got set after that, it would then overwrite the default value, and then it would have whatever value that was. Versus the equal sign. The equal sign says if I ever in any point decide that Jacob, if I write Jacob as the default here, and then it has no value, then Jacob would get triggered. It would use that, and then it would set name equal to the default value. So therefore it would retain Jacob throughout the rest of the script, unless of course it was overwritten at some other point. Now we've got kind of the oddball, and that is the colon question mark. And this one just states, okay, if it has no value, then I'm going to create a error message. And not only that, I don't have to tell it exit 1, but it's automatically going to do an exit 1. So it's going to stop our script if that variable has no value at that point. It's going to echo out the custom error message. It's going to, actually, it's going to do the name of the file. I don't think I have it in here. It's going to do the name of the script, and then it'll do the line where the error occurred, and then it'll do your custom error message, and then of course execute that exit 1, kick it all out right there. Now there's one strange thing right here, and we'll look at it right here. So here I have an ls. Let's say that I'm trying to list some directory within a script right here, and then I'm using a variable because the directory could change. So at this point, though, let's say that it never got triggered, so it doesn't have a default value there, or sorry, it doesn't have a value. Then this custom error message would then be triggered, and the script would, of course, it wouldn't perform the ls. It would actually exit out of your script. Now, if it had a value, then it would simply do an ls on whatever directory you gave to it, and then we would know nothing about this as far as from the output goes. So that works perfect right there. But a lot of times you simply want to check a variable if it has a value in your script. And it may not be within an echo or some command attached to it. And Linux provides a very, very strange method of doing so. And that is this colon right here. And I think it's on the next slide. So a colon allows expansion to occur. So in other words, it allows a variable to be evaluated. So anything with that $sign, but prevents its execution. And I think if I didn't write this down. Let's see if we did, so if we have the date command here, and let's just say I decide to create a variable called today, and then I am going to make that date. So if I was to say echo $today, you can see it's going to just be date. That's all it was. Now, the funny part is if I go over here and I just say today with the $sign, then I get the date. Does anybody know the difference, why that is taking place? Kind of important to understand about the colon thing. What you got?
So if you're just calling today by itself with a $sign, then shell is interpreting as if you're calling the date command. But then if you put it in an echo, it's more like a string.
Yes, yes. So right here, the echo expects a string, so it's outputting a string. That's perfect. So when it was evaluated, the string was date. But here we do not have echo here. So it's just the shell's just going to evaluate what this ever it is, and it turns out it was date. And then it's going like, oh,
I know that. That's my date command. But now if I was to go over here, let's just say the date is March. So I hit enter. Now, if I was then go today, look what happens.
it evaluates to March. Then, so it thinks that you just type the word March. Well, the first thing you type after the $sign is always some type of command. You always tell it to do something. So it's looking for a command called March. Well, it doesn't exist in our system right there.
So now understand that what the colon does is if I hit enter, we get nothing. Because what it did
In the background, it did evaluate to today, to March, but then it said, okay, I evaluated it, but I'm preventing any type of execution from taking place.
So it's basically going to evaluate, then ignore. So if we understand that, we can go back to an example. I'm going the wrong way. Yeah, null and unset. So we'll do vim null and unset here. All right, so here I have a script kind of showing us how this all works. So I just got two variables. One is color and then color2 here. And of course, it's accepting the arguments that I'm giving it. So $1 gets color and then $2 gets color2. So whatever I give the script as an argument, it will apply to both of those. And then here, I'm just letting us know which one we're evaluating. So here we're doing the :-, which is here's the default value, use it, throw it away. So at first right here, if we're just echoing out color. So if color has no value, it should give a default, or if color has no value, then it's going to display nothing. Here, I'm giving color a default value. So if it has nothing, then it should actually use blue. And then again, it's going to throw it away. So when I echo out color again, it shouldn't have a value. And this one, we're doing the :equals. So if again, color has no value, this would be empty. If color has no value here, it should be blue. And then it should hold on, it should retain that value and then echo out blue again. And then this last one is just it's color2. So here's both of these are using the kind of the first argument right here. This one's using the second argument, and it's just going to try to echo out the value. And then here I'm giving it that default value. So if it doesn't have a value, it should trigger an exit on our code and just say color2 not assigned, just some error message right there. So let's take a look at it working. So first /null, and then I'm going to give it absolutely no values whatsoever. So if we hit enter, then you can see, so color had no value, so there's nothing to do. Again, it had no value, so it defaulted to blue. Here it had no value because that was the :-, so it didn't retain it. So it still has no value, which allows our :equal to work. So again, color has no value. Here it has the default value. It retains it because we're setting it equal to it. And so it has the value. And in this one right here, it triggered our error because color2, the second argument, didn't have a value. So you can see the name of your script. Oh my goodness, someone's blowing up. Let me mute that. And then the line that it took place. Here's the variable that it was. And then here's our custom error message. And then if we were to echo $, hang on, somebody tell me, echo what? If I want to get the success or failure of the previous command. Anybody remember?
Question mark?
$? All right, perfect. This is important concept because here it actually failed and we set, and this thing, we didn't set it to exit 1, but it does it by default exit 1. So it actually retains. So this not only does it do within the shell when it runs, but when the shell, if we create the custom exit code for the shell, it's going to retain that and we can actually get whether our script successfully completed or not as well. All right, now let's go back and run it. And I'm just going to give it green as the first argument. Now you can see that nothing really matters because it had a value right here. So here it had its value. The default value does not trigger because it only matters if it's empty. And then so green, green, green. It just ignored all of the default value stuff because it doesn't matter if it has a value. Of course, this one's still triggered because we didn't give it an argument. So if we go down here and just do red, then you can see that now none of them get triggered because our variable color 2 now has red. So it just acts as normal. So again, I can't say it enough. It only matters if it has no value whatsoever. Any questions? What you got?
Given the nature of just colon on its own, could you use it essentially as comments?
Comments in your code? You probably could. I don't think it would trigger an error. And it would just ignore it. The question is, would it? I don't think it would even print a line or anything as like an empty line. I've never tried it, but I think it would work. I don't think it would be a best practice or anything, but it would ignore everything that came after it. Any other questions? All right, I really need to put this earlier in the lectures here, but I keep on forgetting every semester. So we're finally reaching the read here, which we've already messed with several times, but we'll expand on it. So again, we have a read command. The -P is an option that tells it, that tells it to create a prompt. And then here's our prompt right here. And notice that it's always good to put a space. So that way, when you type the text, it's not butting up against that. And then in this case, we haven't seen this. We have 2 variables right there. Of course, we can name these anything we want. We are creating the variables. These are the variables that is going to capture whatever we type right there. So it's going to just give us a single prompt, and then we'll just type one word with a space and then another word, and then it's going to capture it. And then I have just some echo statements for word 1 and word 2. So when we run it here, you can see we got apples and oranges is what is being typed. And so then it just echoes out. Now, one of the important things to remember here is this. In this example, we do apple, and then we type oranges, bananas, and kiwi. But in our script, we only have 2 variables. So what takes place is this becomes 1 variable. So you have apple here, and then $2 here, or word 2, sorry. It just captures everything else. All right, really all you need to remember from the list right here is 1, you can use read just by itself. So no prompt. And then if you just do read, it'll actually just capture whatever you type next after it's run. Some people like to just use read by itself. And then of course, -P right here, that's all you really need for this class. I prefer the -P because if you do that, it allows you just to tack on right after the prompt, versus some people will do like an echo statement and then do a read after it. So then it'll kind of have a prompt, but then you enter things below that, but there's really not a good indication when you do it that way. I guess I can show you all that real fast. So if we just did, let's do, nope. Yeah, echo, let's say enter name. And we'll do that and then close it up. We'll do a read after it, and we can just say name. So that's my variable that's going to capture it. And then another semicolon, and then we can say echo $name here. So if I hit enter, you can see it's going to give me that prompt, but the prompt is now below instead of at the end. And then I could enter my name right here, and then it's going to trigger that echo right there. Does anybody remember a way that I could actually not do name right there? You remember what the variable is that would capture it automatically? So I can delete that. I could go over here and I could use reply. So reply always in the background captures whenever you are prompted for information, reply will capture that all the time. So if it's something that's very, very simple like that, you could shorten it and not even do a variable. But if you want multiple variables, then reply kind of goes away because there's no way to separate it, because it only remembers the very, very last thing that you type. Oh, yes, redirecting into control structures. This one right here racks the brain of some students every once in a while here. So we've seen how we can redirect a file, right? And then again, everything we do on the command line, we can do where?
That's good.
In a script, perfect. And so we can also use redirection within our scripts and redirect something right into a control structure. And I like to actually do this on the command line here. So let's cat out names.txt. Then we'll cat out this read file. So we'll do them first. All right, so in this example, we have a while loop. So you can see we're using while. And then now we're giving while an actual command of read. And what do you think first and second is? What am I declaring there? The what? They are they would be arguments to it, but what have I showed you? What comes after read? What type of argument? What is it doing? They're variables that are capturing data. So that's literally what I'm doing right here. I'm giving read, it's two variables to capture the data right there. And then when it captures that data, I'm switching the data around. I'm saying echo second, a literal comma right here, and then echo first. So it's capturing two different strings right there. Now I'm just rearranging those strings, and then we have our done. So here is our while loop right there. Now we have a redirection operator, and then we have this names.txt. So something important to understand that just like on the command line, if I ran this on the command line, I have access to all the files within that directory. Well, because this is in the same directory as my script, so I have names.txt and this readfile.sh, they are both in my present working directory. The script knows that, and it can actually reference those files within it.
If you did the redirection with the name.txt in the while loop, like after the echo, would it still work, or does it have to go after done?
No, it would have to go after done. It needs to be directed into the actual loop there. So let's take a look. If I can get that. So right here, we have our names right here. So if I run /read file, then you can see that we got Alicia. So Alicia would have been the first, Jones would have been the second. Of course, you renamed it to second in literal comma and then Jones. And then that same thing, if we actually look here, we got John Q public. So John would be first, and then Q public would be captured in second right there. So you kind of get that weird one right here where it's Q space public, then comma John right there. That's because this was our second variable capturing all that information there. All right. Any questions on that? Because that will come in handy quite a bit and when you're writing some of your scripts later. All right, trap command. We've talked about signals, and signals were a way to actually interrupt programs. So remember, we could actually list them with the kill command in there. So they all have kind of like their default actions that they perform. Well, we can actually change those default actions right there with the trap command. So if we know that the user may press a certain combination and we want it to actually do something else with our command, we can basically put a listener out there that listens for those key combinations, those signals that are come through, and then we can create a custom action to take place with those signals. So here is a list of signals right there. I think in our example, we're going to be using this int. So notice that you could reference as sigint, you could reference it as int, or you could reference it by the number, which is 2 there. But all of this is Control-C on our keyboard. Now, the one thing to remember is there's one signal that cannot be interrupted. That is kill-9. So that is the one, if you remember, if the regular kill command does not work, then we have kill-9, which, it doesn't save, doesn't preserve anything. It just absolutely shuts the program down and it loses all the information. That one cannot be trapped. But the default one right here, the one that tries to save the information and gracefully shut things down, you can actually trap that one if you want. And again, just more of a list of stuff you can trap. And then here we have an actual command, and I think mine's got a little bit more to it. So we'll take a look at that one. So let's do vim trap. Okay, yeah, it's all there. All right, so in this one, I got the trap command. Now, one thing to remember on this, and it's kind of strange, is the trap wants all of the actual commands that it does to be inside single quotes. And that looks weird right here because, you know, we expect echo and then the quotes to come after, which it does right there. But these are kind of just special to trap right here. All of the code has to go in between those two single quotes or it's not going to work. So we have a trap, and then the next thing it expects, okay, what do you want to do if the trap is actually triggered? Well, I want it to echo, and I'm doing the echo -e, so that way the /n gets processed within the double quotes right there. So it's going to do a new line, and then it's going to echo the current PID. So it's going to get the process PID right there, the current running process. It's going to get its process ID, and then again do a /n. So it's going to do an enter. And then on the second line, it's going to say program interrupted and then do an enter again. And then it's kind of hard to see right here, but then I'm going to trigger an exit 1 because this would mean it's a failure in this case if this happens. And then lastly, outside of those single quotes is going to be what signal are you actually looking for? Of course, we're going to do int, which is SIGINT, or, you know, Control-C on your keyboard. So that's what's going to be listening. So it's just going to set that out there. It's going to be actively listening for that to take place. And while it's listening, it's then going to go and do all the code we have here. So I just created a infinite for loop called while true. So while true is true, it's just going to echo the program is running and then do a 1 second sleep. And then so it's just going to sit there and echo that forever on our keyboard here. So kind of created an infinite loop. And it's just going to sit there and run forever. Now, if I do Control-C here, then you can see that it did and it will always, when you interrupt the program, the shell is going to print the !C to let you know that it was a Control-C that was pressed. And then here's our custom error message. So here was the process number of the actual script that was running. And then we have our message right there, and then the little extra enter at the end there. And note that I really didn't change the Control-C is going to end a program anyway. I didn't really change it. I just added a custom message to it when I could have done something completely different. I could have had it call another script if I wanted to, and then run a different program. So a good example of that, if you've seen the ping command. Ping command uses the same concept. Control-C should just cut this thing down, but it actually interrupts it and says, okay, I'm going to use Control-C as a mean to spit out the actual results of the ping there. All right, I think this is one of the last things we have that I want to cover today, and that is eval. And we'll just set this up in the actual terminal right here. So we could say m equals 2, and then we'll say n equals 5 here. So I set up those two variables. Now, if I was to echo out those variables, that would be, you know, simple. We could do $m and then $n. Should do quotes, but I didn't. And so we can see it evaluates no problem. Now, what I'm going to do is, if you can recall, the thing called sequence. So if I did like 1.5 here, then it should count 1, 2, 3, 4, 5. Well, here is the problem. If we want to actually use variables in that, so if we did $n and we tried to count to $m, did I do that right? No, it should be m to n. And then I hit enter. You can see there's a problem right here. And that's the fact that the shell can't do both of them at the same time. The evaluation and expansion, it just can't do both of them. So that's kind of one of those downfalls. You rarely ever will you need to use eval, but it's one of those things when you run into and you're like, this is very, very strange. I don't understand what's going on. It's just it can't do both at the same time. Well, that's when you pull in eval to actually perform the evaluation of all the variables beforehand, and then the expansion can take place secondly. So you can see you just got 2, 3, 4, 5 right there. So it's more like a workaround fix for some of the limitations of the shell there. All right. I think I want to stop right here because we're going to go over the exam. We'll pick up on GitOps and end with bash arrays on that, and that'll give us everything that we need. So want to point out one thing, because we're stopping in the middle of this, you will not see the associated homework just yet because we need to get through everything in here. I'm trying to think. Yeah.